Hello everyone, this is Revathi working as an assistant professor in information technology from SNS College of Engineering. In my today lecture series, we are going to see about a presentation about Knapsack problem which was presented by our student. Thank you.
Hi everyone, I'm Subhash and today we are going to talk about knapsack problem. So knapsack is a part of greedy algorithm and today we are going to discuss what it is and see how it works. And I am Subhash and my teammates are Kola Praveen, Harini and Harivarshan. So further down they will be explaining the remaining parts and now I will go in the introduction. Introduction. So let us first know what is a knapsack. So it is a classic optimization problem in computer science. It is basically a combinational optimization, that's what we call. So it involves selecting a combination of items to maximize the value while staying within a given weight constraint. Let us say there is a maximum capacity of a bag and there are multiple items. So the part where knapsack comes into place is we have to maintain that the bag is full, but at the same time the value of the items that we put inside the bag is also worthwhile. So let us move on to the algorithm. So knapsack problem algorithm. So first we have to initialize a maximum value. Okay. So every bag has a maximum value. So if the bag's maximum value, let us say it's zero, then it can contain only zero number of items. So the total overall maximum value will also be the zero. So then we will fill the table iteratively. So if the maximum value increases to 10, then we can put number of items 10. But if only each item values to 1 and its weight is 1. So if the item's value and the weight differs, then the amount of items that we fill in the bag will also differ. So to find how this works, we use the recurrence relations. Here you can see dp, which is the bag. So the bag of I and w is equal to max of I is item minus 1 into weight. Okay. So another formula is bag of I minus 1 and w minus weight of I. So weight of all the items plus value of I, value of all the items. Okay. The final result will be the maximum value in the bottom right cell. Okay. So we can backtrack this to retrieve the included items simply. So this is how a knapsack problem algorithm works. And further down will be explained by my teammates. And thank you.
So hi guys, I'll just be explaining a problem example on knapsack problem. So we have taken a knapsack. So there's a bag with a maximum capacity of 10 units. So we have four items here, each with weight 2 units, 3 units, 5 units, and 7 units. The respective values of each weight are $5, $8, $12, and $14. Okay, so weight. So the item one has a weight 2 units and value of $5. So what is the maximum capacity that it can be kept into the bag? So that the bag has a maximum value and it is also under the capacity of the weight. So we can add we can bring in the first item, the second item, and the third item, so that the addition of all these units will become 10. So it satisfies the condition of the maximum capacity of the bag. But we are also checking the value. So we have to check the maximum value. So we are adding here the value. So it gives the value like 8 plus 5 is 13 and 13 plus 10 is 25. So we get $25 of value. So we keep three items and we have $25 of worth value items. So the second possible solution is we are taking item 2 and item 4, which gives us the weight 10 units. So 7 plus 3 is 10. So we are also having the values like 14 plus 8. So 14 plus 8 gives $22. So we have two items here and the value is $22. So there are like no other possible solutions here. So the maximum capacity and the maximum value which gives us item 1, 2 and 3. So we have to bring in all three items and we also have the maximum value of $25. So this is how an knapsack problem works. So if the solution is not satisfied, we backtrack to the next solution and also check it whether if it is under the condition and it also satisfies the maximum value condition.
Now I'm going to talk about the one of the greedy approach of the knapsack problem. It is fractional knapsack approach. The basic idea of greedy approach is to calculate the profit weight ratio for each item and sort the item on basis of this ratio. Then take the item with the highest ratio and add them as much as we can. We can also take the whole element or take a fraction of it. This will always give the maximum profit because in each step it adds an element such as this is the maximum possible profit for that much weight. So let's get into the coding. So first we need to define the structure of the item and which stores the weight and the corresponding value of the item. So then we need to specify the greedy function to solve the problem. We will take the 0.0 as the initial final value, and we look through all the items and add the current item if it does not overflow, and we can only add the fraction part if the adding item won't overflow, we add it completely, or if we have only add the fractional part of it, then we return the final value. That's all about the code.
I'm going to share you about the uses and applications of Knapsack. So, coming to the uses and applications, finance. The protocol optimization in finance. The Knapsack is utilized to optimize the investment profiles by citing the most profitable combinations of assets while considering the factors like risk and returns. So logistics. So inventory management in logistics, the problems helps in optimizing warehouse management and packing processes, ensuring effective usage of space and resources. Cryptography. So in data encryption, the knapsack problem is applied to create a secure encryption algorithm where the challenges is to find a subset of numbers that sum up to a certain value within a given range. So let us see the advantages of knapsack problem. The applications to the diverse real world problems. The knapsack problems is versatile and can be adapted to various industries and scenarios, offering solutions to optimization challenges in fields such as finance, logistics, and cryptography. Flexibility in handling the various constraints. It does accommodate different constraints such as weight, limits, value constraints, and item availability, making it suitable for addressing a wide range of optimization problems. Disadvantage of knapsack problem will be discussed along with you by my team at Harivarshan.